T4. Mini T4. This is T4 in your zone.
So our topic for today is all about general atmospheric circulation. But before that, we must recall what is atmospheric pressure.
Air around has weight. Really?
Yes, it is called air pressure or atmospheric pressure. It is the force exerted on a surface by the air above it. As gravity pulls it to Earth, this pressure is an indicator of weather.
Moving on, let us tackle atmospheric circulation.
It's any atmospheric flow that refers to the general circulation of Earth and regional movement of air. The general atmospheric circulation has subtopics, which is
polar cell, carousel, and heavy cell.
But why it has cells?
Because more solar energy hits the equator, the air warms and form a low pressure zone.
If Earth is not rotating, there will be one convection in cell in northern hemisphere and one in the southern.
the planet's rotation means that the Coriolis effect must be taken into account.
Do you still remember your previous lesson from you were on grade 10? There were two types of movements of ocean currents, which is counterclockwise and clockwise movement of ocean currents. And yes, those are formed by what we call the Coriolis effect.
How so?
Air rises at the top of the troposphere as it moves towards the pole. It also deflects the light.
Both batches of high descent creating a high pressure zone once on the ground. The air returns to the equator, which is called Hadley cell and is found 0 degrees and 30 degrees north.
0 degree cell is between 30 degree north to 60 degree north. This cell shares its southern descending side with the Hadley cell to its south.
The last cell is polar cell, located between 50 degrees and 60 degrees in North Pole where cold air descends.
The subtopic is called Tressel's modal.
Climate is a general pattern of weather in a certain area over a long period of time. On other hand, weather is a condition of atmosphere at the specific place and a specific time.
And that would be the first topic that we've discussed. Now, let's move on to the next one.
Let's now find out what ocean currents are and how do they affect the climate.
Ocean currents are large-scale movements of seawater that flow through the world's oceans. These currents are various types of... Wait lang, kalimutan ko.
There are two types of ocean current. The first one is
Space currents. This occurs in the upper 400 meters of the ocean and primarily driven in the winds.
The second is deep ocean currents. These flow below the surface and are driven by differences in water density due to temperature and salinity variations.
Now, what are the relationship of ocean currents to climate?
Ocean currents act as a conveyor belts of warm and cold water, sending heat toward the polar regions and helping tropical areas cool off. The world's ocean is crucial to heating the planet, while the land areas and the atmosphere absorb some sunlight. The minority of the sun radiation is absorbed by the ocean.
Ocean currents help regulate global climate by distributing heat from the equator to the poles.
Affect weather system and can affect coastal weather conditions.
In conclusion, ocean currents are essential components of Earth's climate system.
Understanding their dynamics is crucial for predicting climate changes, managing marine resources, and safeguarding our coastal regions.
Hello, Maglamanta! Goodbye! Mini T4! Mini T4! T4. Thank you for watching.